Introduction. Agriculture has long been used to produce food, and it is a crucial source of income for all people across the world. In details, every leafy greens have distinct qualities of its own. Therefore, they have distinct characteristics that set them apart. That's why the leafy greens are all not the same, even though they seem similar. And it is very challenging to distinguish between types of leafy greens. And we have created a system using image processing and machine learning to accurately recognize and match images with database information.
Next, for the problem statement, the first one is every leaf has distinct features of its own, and there are many different varieties of leaf available. Next problem statement is to implement a convolution neural network, especially for the hidden layer, to classify the input leaf images. And lastly, the system should have a high percentage of accuracy on validation to make it easier for the system to identify the different types of leaves.
The objective of this project is to develop algorithms and systems for leaf recognition through image processing and machine learning to automate analysis and classification of various leaf types, and also to increase efficiency and accuracy for leaf classification.
The scope of leaf recognition using image processing and machine learning is broad and diverse, as it can be applied to a wide range of fields such as botany, forestry, agriculture, and ecology, and be used to address various issues related to plant identification, forest inventory, agriculture, and ecology. The project aims to apply plant identification through leaf recognition using image processing and machine learning, which can have a significant impact in sectors such as botany, forestry, agriculture, and ecology. Automating the process of leaf detection can increase precision and efficiency while reducing the time and expense of manual analysis. The project aims to enhance our understanding of the natural world and improve our ability to manage and conserve resources using cutting-edge techniques to increase the precision and effectiveness of leaf recognition.
So next is a methodology. For this project, our group was given a dataset with 4 leaf classes, which are class 13, class 17, class 18, and class 22. The dataset was obtained from Google Classroom. Each of the classes was provided with 52 images. We were assigned to choose only 10 images from each class, making a total of 40 images. The dataset will be used to train and test the given model. From these 10 images, we use only 8 for training, and the remaining images will be used for validation. So, based on the flowchart, the first step is to read dataset and input image from the folder. The next step is we need to resize the image. The third step is we need to convert the image from RGB to grayscale. So the next step, the thresholding will be performed to convert the grayscale image to the binary image. And the next one is we will apply the opening operator on the image. In step 6, we will apply average filtering on the image where it can remove the small details prior to the large object extraction. And the next step, after we have applied the average filtering, we will fill the image regions and holes. So after we have filled the regions, then we will start to train our network using CNN that can receive image as an input and use them to train a classifier. So the system will split the image dataset into a training set and a testing set. So the split is done for each class by randomly by choosing 8 images for training, and the rest 2 images will be for testing. So after we are done with the training network, we will get the accuracy result for validation. So in step 10, the input image will be classified using the network that we have trained before. The higher the accuracy result, the more accurate the result of recognition will be. And lastly, the system will display its class for the input leaf. So So this is a result and analysis for our system. So here we have input, expected class, and output. So supposedly for output must be same with what we expected. So as you can see in this table, all the expected class are same with the output, which means our system correctly categorize all the input into their classes.
For the conclusion, we have successfully to identify the 4 types of leaf from 4 different classes. We also have applied the convolutional neural network to test the identification of the leaf. The primary programming language matrix laboratory known as MATLAB are used to code and build the image processing system. To conclude, the highest accuracy and validation of the leaf is 100%. And lastly, we are able to implement a useful system for the use of students and future researchers.